Hey everybody, welcome back to our last video dealing with interference. And here we're just going to discuss how a simple hologram works, what's called a transmission hologram, and how it's related to interference. So this is just a schematic of how to make a transmission hologram. And you guys probably have seen demonstrations of holograms, and after I describe this schematic, I'll show you a video of some transmission holograms that we have in our optics lab. And again, when I see you in person, you can have a chance to look at them in person also. So it relies on the interference of light. And so we're going to use a laser again because we want to get a nice interference pattern that we're going to record on a piece of film. So here's what we do. Here's the laser up here. It's going to send a laser beam. Now we want to be able to get two beams to travel different paths so that they interfere. So we have a beam splitter, okay? And part of that beam then, let's trace the part that reflects. So it's going to reflect down this way. Now we have to spread the beam out. So that's what the role of this lens is. It's just to make the light spread out, diverge. So you see it. Now, there's a mirror here. You wouldn't necessarily need this mirror, but I have it here just so I can fit the schematic on one page. So this beam is going to get spread out, and it's going to come and hit this piece of film. So this is just a piece of film that is used like it used to be used in old cameras. You expose the film to light and then you develop the film, right? That's what we're going to do. But you notice this beam really isn't hitting anything, right? It's just going here and it's going to hit the film. This is known as the reference beam. The other half of that, an incident laser beam though, if we trace that, that's going to get spread out or diverge. It's going to form a diverging ray with this lens. Diverging rays with this lens. And again, this mirror is just here so I can fit this on the screen. I mean, your actual setup, you're going to have some mirrors somewhere to direct these beams, but the mirrors themselves aren't key to the interference and the production of the hologram. So here's the object. So this is what we want to make a hologram of, this particular object. So this lens again is going to spread out this light, and this spread out light is going to hit this object. We want to flood that object with that light. Some of that light is going to reflect off of the object. That is what we want to direct, that reflected light beam, onto the film. So this is known as the object beam, that the light that reflects off the object. Now, here's where the interference is occurring. It's on the film. So the reference beam, the light in the reference beam, is interfering with the light that's reflected off of the object. So the light in the object beam. And so you're getting, at the film, you're getting points of varying brightness. That is recorded onto the film. So you expose the film to that pattern. And by the way, that pattern doesn't look like anything special at all. Okay, so, if you look at that pattern, you don't really see anything. It's not going to be a beautiful set of circular rings or fringes or anything. But you record that on the film. Then you develop the film, okay? And when you're done, you have this piece of developed film, and by itself, it's just this thin layer of film. It doesn't look like much. However, what you do is, with that developed piece of film, if you send the laser light through that film, and it doesn't have to be the original wavelength, the same wavelength necessarily, but if you send that light through the film, what will happen is that when that light hits that film, there are going to be regions of varying transmission. So where there was a really bright spot, the film got exposed with a lot of energy there. When that gets developed, then that is going to be a point that has a different transmission than a point on the film where there wasn't any light. So really the film has these regions of varying transmission. So when the laser light goes through that film, what'll happen is that it will spread out. It will actually diffract around those areas of different transmission or different opaqueness. And when that light enters your eye, your brain will think that that light has come from whatever produced that interference pattern. So the way the light diffracts around these areas of different transmission, when you catch that light in your eye, you're basically going to see what produced this interference pattern. So what you're looking at is a hologram of the object. Okay, so in short, what this film is doing is recording the interference pattern of light that is reflected off of this object with this reference beam. And when you shine light through that developed piece of film, the light that enters your eye, it will be traveling in such a way that your brain will see what produced that interference pattern. That's sort of a simpler way to describe it. Okay, so let me go to the video then. And I have, I think, 3 different holograms. Oh, I'm sorry, I'm in the wrong place. 3 different holograms. Okay. So, whoops, sorry. Okay, it's this video. So I'll make this a little bit bigger. All right, so first I'm showing you the laser. We'll go ahead and run this. And the laser, I'm going to shine the laser through this microscope objective. Let me back it up a little bit. See that right there? Whoops. That is a microscope objective. So that's a short focal length lens. So what's going to happen is that the light is going to focus really quickly, and then after that focal point, it's going to diverge. That's just going to allow me to hit the hologram, the film, with a big spot of light. Here's the actual film. I'm holding it now right there, and you can see it doesn't look like much, right? But when I put that, it's just a thin piece of film. But when I put that laser light through there, turn the lights, look at that. Okay, so let me just pause that. So we've turned the room lights off, and now the camera, the video camera, is catching the rays of light that are coming through that film. And the way that they are traveling, you are going to see, the video camera is going to image what produced that interference pattern in the first place. And this was a little toy sailing ship. I think you can make that out in the hologram. And what's neat is you get this 3-dimensional nature to the hologram, right? Because again, you're seeing what produced the interference pattern, so it keeps that 3-dimensionality. Here's one. I think this is little figures of astronauts on the moon. Yeah. Can you see they're little astronaut, toy astronauts with a little American flag standing on the moon. And in this one, this is cool. This is a pocket watch with behind a magnifying glass. And what's cool is if you look at the pocket watch through the magnifying glass, you'll actually see that it magnifies. Now again, this is just a hologram. It's just a piece of film that we're sending the laser light through. And as you move your head around, you can't really do it in the video, but if in person, as you move your head around, again, you'll see what appears to be a 3-dimensional object. Okay, so that's how a transmission hologram is produced. Again, it uses the interference of light. It records the interference pattern formed by an object with the reference beam. So then when you shine light through that interference pattern, as the light interacts with those different regions on the film, it spreads out in such a way that if your eye catches it or a video camera catches those rays, you will see what produced that interference pattern. and there will be a three-dimensional aspect to that object. Okay, very cool. All right, that's it. I'll see you in the next video where we're going to talk about diffraction in more detail. So this is the last video where we talk about interference phenomena. Bye-bye.